So let's begin on this. I mean, one of the things that I've realized that is so important is that our bodies actually evolved for an optimum state over the course of hundreds of thousands and millions of years ago. And if you think about why people are obese, for example, today, a lot of it is the fact that, in ancient times, there was no Whole Foods down the street.
True.
And there was no place you could go to get a regular meal, so your body learned to store every fat calorie it possibly could. But I think one of the insights I got from reading your book was that what our genetics, what the molecular machinery of our body evolved to eat was what we ate thousands or tens of thousands or hundreds of thousands of years ago, not the stuff we eat today.
Correct. Yeah.
And we're paying the price for mismatching what our body ideally wants and what we give it.
Correct. Yeah.
So that seems like a really logical thing. And I'm just curious about the journey you went through to figure out what the optimal health diet is. And do you mind sort of starting with that? Like,
Sure.
What's your story there?
Well, as you know, I was a very famous heart surgeon and invented a bunch of stuff and did pediatric and baby heart transplants with my partner, Leonard Bailey. But before that, at Yale University, back in the dark ages, I actually had a special major where you could spend 4 years with 3 professors and write a 10-page little research project every week and then have a thesis that you had to defend at the end of 4 years. And that's the only classes I went to. Interesting.
Yeah, I like that self-guided education.
Yeah, it was a dismal failure because none of us could get into medical school because we all had satisfactory. But anyhow,
I think you did okay.
So we had my major was human evolutionary biology, which we would now call epigenomics and nutrigenomics, but we didn't have a word for it.
Right.
And what I did was, my thesis was you could take a great ape and manipulate its food supply and manipulate its environment and predict that you would arrive at a human being. And that was my thesis. And I successfully defended my thesis and got an honors. And I basically was one of the early people that said we actually began as an aquatic ape.
Oh.
Yeah, and we can go into that later, but it's an interesting theory. That's why we have a big brain.
Huh.
And it's actually why we're hairless. So anyhow, I put that aside and went to medical school and became a surgeon. And then I was running 30 miles a week, going to the gym 1 hour a day, eating a healthy vegetarian diet at Loma Linda University, where I was a professor. And I was really overweight. And I had arthritis, I had high blood pressure, pre-diabetes. I actually did baby transplants with migraine headaches. And
with you having migraine headaches at the time. And just pause 1 second, because I've heard this from many people, right? You do all the right things. You're exercising, you're eating healthy. Okay, you have that little bit of chocolate once in a while, but we'll find out actually polyphenols from chocolate.
It's fantastic.
And from
coffee.
Caffeine is good for you. And you do all those things and you still don't lose the weight. And you're saying, what the heck is going on here? Is it genetic? Am I just predisposed to always be this? But it may well be that you're not actually eating the right things.
Correct. And I was told it was genetic because everything was exactly like my father's. And I go and they say, oh yeah, you got high cholesterol because your dad does, and you're pre-diabetic because your dad is, and you have arthritis because your dad did, and you have high blood pressure because your dad did, and it's genetic. And just, get over it.
How much overweight were you back then?
I weighed 230 pounds. I was about 70 pounds overweight.
You don't have that right now?
No. So I met a guy who changed my life. He was a big fat guy from Miami, Florida with inoperable coronary disease. And I'll shorten the punchline. He cleaned out most of the blockages in his coronary arteries in 6 months by eating a particular way and taking a bunch of supplements from a health food store. And I told him he wasted all his money with supplements. He made expensive urine, which I firmly believed then. I don't anymore. And I told him, good for him for losing weight. He lost 45 pounds in 6 months, that he wouldn't do anything in his coronary arteries. But we got another coronary angiogram on him 6 months following his first one, and this guy had cleaned out most of the blockages.
So this is like a calcium score reduction?
Yeah, not calcium score.
This is
calcium
this
score,
is visual.
This is an angiogram of your heart, and we can see the plaque.
Yeah.
Calcium score, believe it or not, just kind of tells you what's on the outside of the arteries. Mm-hmm. So I said, tell me how you did this. And he starts describing the diet. And I said, whoa, bells went off. I said, wait a minute, that's my thesis at Yale. And so I called up my parents who live in San Diego, and I said, hey, do you guys still have my thesis? And they said, yeah, it's here in the shrine,
Of course.
the perpetual flame. And I said, oh my gosh, send it up to me. So I put myself on my thesis. And
on the diet on the evolutionary diet.
Yeah, on the evolutionary
so
diet.
what was it, how far back in time do you think our genetics optimally developed for the plants back then?
Yeah, so, we're descended from a tree-dwelling ape. We're basically a tree shrew, and tree shrews have been around for 40 million years. And the ape line came out of tree shrews. And so we were designed to actually eat two-leaf plants out of trees primarily, dicotyledons, remember?
Right, from biology in 7th grade, yes.
Yeah. And there are other animals, the grazers, that are designed to eat monocotyledons, the single-leaf plants, the grasses.
Right.
And we're designed to interact with the compounds in two-leaf plants. And we've been interacting with them for millions of years.
Yeah.
And one of the things that's interesting is that these plant compounds also interact with our bacteria. And our microbiome is actually the initial greeting committee for what comes into our mouths. Everything we put into our mouth is actually foreign to us. It's completely foreign material. And it has its own proteins that are foreign. And what those proteins carry is information. Mm-hmm. And so the bacteria are actually designed to eat certain plant proteins better than other plant proteins. And they're designed, if everything's right, to communicate to our immune system that the things you're eating, hey, we've known these guys for 40 million years. Yeah, they're a pain in the neck, I know, but you don't have to get all upset about them. We know them, chill out. Yeah. And that actually worked incredibly well. We continue to eat a lot of plant leaves for most of our evolution. But one of the things that changed dramatically, probably 150,000 years ago, 100,000 years ago, is we harnessed fire. And fire was actually the major leap that made us human, because all other animals, all other great apes, can't break down the cell wall of a bacteria, can't digest it. We have no digestive ability to do that. Yeah. And we require bacteria to do that, to ferment the cell wall.
And by the way, just a slight pause here, just to remind folks, as a human being, you are a collection of somewhere on the order of 20 to 30 trillion human cells that make up your body. 100 billion of them make up your brain. And we also have in us about 10 times the number of bacteria, fungi, virus, and so forth, your microbiome. And what we're learning, I mean, you've heard me talk about this at the work we're doing at Human Longevity, is that your microbiome is extremely important to your health.
Correct.
And your state of mind, how you feel, whether you're obese, whether you're skinny, a whole slew of things. And it's incredible in some of the things that we've talked about before in eating and microbiome, the connection there.
Yeah. We've talked about this before. I'm convinced that because they contain so much more genetic information than our own genome, and they're capable of rapid genetic change and rapid growth, that I and a few others think that we've actually uploaded most of our processing and decision making to our bacterial cloud.
Yeah.
Because they're actually...
I love that term you use, the bacterial cloud, as sort of a additional processing capability.
Yeah, and it makes sense to me because that's where the rubber meets the road. Everything that we ingest has to come through our bacterial processing.
Yeah.
And it's a hard concept for us to get around that bacteria could actually tell us what to do. We're basically a condominium for bacteria. And we're an incredible symbiont. And we've made a deal with these guys to teach our immune system what to do, teach our brain what to do. We know that young bacteria, when we transplant them into old mice, make the old mice young again. And we can get into that. It's really voodoo stuff.
Amazing, amazing. And we will be getting into that stuff in the Q&A.